In this video, I want to help you with 15, 16, 17, and 18 on the review. So 15, I'm trying to find the y-intercept. So if I remember, an exponential equation follows this format. A d to the x, where a is my y-intercept and d is my common factor. If I want to line these up with those equations, I'll go ahead, I'll say this is y equals a d to the x. Same here, y equals a times d to the x. G is much easier to do, so if I take g of x, I can see what lines up easily. The 2 lines up with my d, and the a lines up with the 2. So that means my y-intercept, G has a y-intercept of 2. Much harder is f of x. F of x has my d lining up, so this 2 is d, but what's in front of that? Well, what's in front of this is an invisible 1. So basically, f of x is in this format. I have 1 times 2 to the x. And this right here would be my y-intercept. So I know my y-intercept equals 1. Now we've done this in another video here, 16. The transformations are fairly straightforward. This has a transformation from this function that happens to my x and to my whole function. I know that the whole function transformation means up 2, and this transformation means left 2. So together, I'm going to have a transformation that is left 2 units and up 2 units. Is the function linear or exponential, 17 asks? Well, the first thing we need to do to look at these equations is my change. My change in the x is just 1. Oh boy, it's 2 here, it's 4 here, and it's 8 here. My change in y is 5, 10, 20, and 40. So if I'm going to go ahead and do my slope, which is rise over run, or in other words, my change in y over my change in x, I'm going to take all of these. I'm going to take 5 divided by 1 equals. I'm going to take 10 divided by 2 equals. 20 divided by 4 equals. And 40 divided by 8. 40 divided by 8. And the answer to all these questions is 5, 5, 5, and 5. So what can I say about my slope? Well, it's very clear that my slope is a constant 5 through all of these changes. So this function is going to be linear, because if I have a constant slope, then it's linear. Over here, basically, I'm going to identify which function is growing at a, and this is off the screen here, at a faster rate. So if I want to just look at here, all these changes, this is 1, this is 1, this is 1. Now f of x is going by 25, then by 100, then by 25, 50, and then 100. Over here, I'm going by 5 first, or 4 first. Then I'm moving by 15, and then I'm moving by 80. If I follow these patterns, what I'm doing here is I'm multiplying, and over here I'm also multiplying. I'm multiplying by 2 here, and over here I'm multiplying by 5. So obviously my g of x is going to be growing faster.